Hey, what's up guys? I'm Theo Joe, and today I'm going to show you how you can potentially double the processing power of your CPU using a method you probably didn't even know is possible. And this doesn't even involve overclocking, so if you already have overclocked your CPU, then you can still do this method and get even better performance out of it. I'm going to explain how this works, what you need to do, and then we can do a quick test afterwards to make sure it worked. It's actually a pretty easy process, but first let me explain how it works. You see, every CPU that you buy will have an advertised number of cores. And for every core, it basically allows multiple programs to be processed at once on each core. But over time, these different cores may degrade and lose performance. To fix this, nearly all CPUs put out by manufacturers have what are called redundant cores, which basically act like backup cores in the CPU. So if one of the cores fails, a backup core will be activated to preserve the level of performance. And in most cases, there are just as many redundant cores as regular cores. So there really are double the amount of cores as advertised in the CPU, even if they're not all being used at once. This is all meant to increase the lifespan of the CPU, but these days it's really unnecessary because with modern technology, CPU cores rarely ever fail, meaning that in most cases, these redundant cores sit unused for the entire life of the computer, while they could be used to increase the performance of the computer. So what we're going to do is actually activate all the extra cores to maximize CPU performance. And even in the unlikely event that some of the cores lose performance or die, you still have more cores than you started with, so there's really no downside to doing this at all. So then you might be wondering, if there's no downsides, then why do CPU manufacturers not ship them with all the cores activated? And there's really two main reasons for this. The first is so they can control the processing power of different models of different price points of a CPU. For example, a manufacturer may produce only one type of chip, but for a lower end chip, they'll deactivate more cores and just sell it at less money, and that way they can save manufacturing costs. So if you do buy a lower end CPU chip, you may actually be getting the same exact one as a higher end model, just with more chips deactivated. The second reason is CPU manufacturers want their CPU performance to remain stable over time. If they were to just ship them with all the cores activated at once, then as these cores die over time and degrade, the performance of the entire CPU would drop, and this would cause bad reputation for that manufacturer. So what they do instead is underpromise on the performance, so there's a lot of headroom, so even if some cores die or degrade, those redundant cores will replace them, keeping it above a certain level of performance, so you always get what you expect. And for the most part, this makes sense and will keep the average consumer happy, but we of course want the maximum performance possible. So now, why don't we head over to the computer and I'll show you what you have to do step by step to activate these redundant cores and get that maximum performance out of the CPU. Okay, so here we are at the computer, and I'm using Windows 10, but it doesn't matter what version, it's going to be the same process. The first thing you want to do is go to the Start menu and type in msconfig, and if you're on Windows 8 or earlier, you can click Run and then type in the same thing and just hit Enter, and then it might ask you to run as administrator and type in a password. But then this is going to come up, and what you want to do is go to Boot. And be very careful here because you don't want to click anything I don't tell you to, or else it might mess up your boot process. So don't click anything except Advanced Options. And then this is what we're looking for. It says Number of Processors. And I want you to notice something. If we check this and look through here, we have the option to select up to 16 processors, or cores really. But if you look at Intel's website for my processor, which is the 5960X, and you scroll down, it says that there are officially only 8 cores here, and there's 16 threads. But here, it allows us to choose up to 16 processors. So while the CPU only officially has 8, there are 8 more called threads, and the total number of cores is, including the redundant cores, is the threads. We can choose up to 16. So we can choose all that are even unadvertised in here, so that this will allow Windows to boot up and activate all 16 cores. So that's what we're doing here. It's going to be using double the amount that is normally allocated to Windows. So we want to check obviously the maximum number here, and then we can click OK, and don't click anything else, and then OK again. And we can exit without restart here. But we're not done yet because that only allows Windows to use all the cores. So booting is going to be faster, the operating system in general will be faster, but any other actual programs won't be able to see those cores. So Photoshop or Microsoft Word, all those programs won't be able to see those extra cores, only Windows. So we need to activate them for the system as a whole so every program can see it. So to do this, you want to go to the Start menu and then go to All Programs, go down to Windows Administrative Tools, and then find Performance Monitor, and you're going to want to run this as an administrator. It's going to make you type in a password. And here is the Performance Monitor, which is going to allow us to modify the performance settings of different hardware in the system. So what we want to do is go to Data Collector Sets, and then we're going to make a new user-defined data collector, which is going to allow us to collect any other resources, including these extra CPU settings, and make them available to all the programs on the computer. So here, once you select it and click this, you want to right-click, go to New Data Collector Set, and then this is going to come up, and we can call it anything you want. We can call it CPU, and then you want to click Create Manually Advanced. I'll walk you through it. It's not too difficult, even though it says Advanced. So you click Next, and then just check Performance Counter, and then we can click Next again. So then here we want to click Add, and then find Processor. This is already highlighted, and once you do that, highlight the highest number under Instances of Selected Object. Just look for the highest number, and for me that would be 15, and that is because it's going to activate all 16 cores, because the index number 0 counts, so it goes 0, 1, 2, 3, all the way up to 15. So 15 is really the 16th core, meaning all 16. So you want to highlight the largest number. You don't have to worry about how many cores each has, and just click Add. You can see that shows up over here. And then you also want to go to Process, not Processor, in here. You can click this to expand it and look for Thread Count and highlight that, and then click Add as well. And that's all you have to do for this. We can click OK. And then don't worry about the sample interval, that doesn't matter. We can click Next all the way to the end and save and close. So by doing this in the Performance Monitor, it ensures that all programs are going to be able to access these extra cores because they'll be listed in the monitoring system, so they are visible to all programs on the computer. So before launching, they're going to look at this monitor and see those extra cores and be able to utilize them. So now we can just close that out, and we're mostly done. All you need to do now is restart the computer, because of course none of this is going to take effect until Windows boots up with those new options we set, and after that you're good to go. Alright, so after all that, your computer should be much faster, but you're probably wondering exactly how much faster. So why don't we go to the computer again and do a quick benchmark test to find out exactly what kind of performance increase we just got. Okay, so for these tests, I'm going to be using a benchmarking program called Geekbench. It's pretty standard for CPU testing, really popular. So the first test we're going to do is before the upgrade. As you can see here, it is not checked, so it hasn't booted with the extra number of processors that were hidden, so we can get rid of that. And I'm just going to run this test, and then I'm not going to make you guys wait for it. I'll skip to the end and we can see the result, and then we'll compare it to after doing the upgrade. So I'll come back when it's finished. Okay, so the test is just finishing up, and we can see the results for the baseline test. Find that out, and it looks like it is going to be 12,879 for the multi-core score and 3,324 for single core. These numbers don't really mean anything right now, but we can use them to at least compare to the second test. And I expect the single core test is going to be the same, because obviously each individual core is going to be the same performance, but we should see a big jump in the multi-core score, obviously because we're going to be doubling the amount of cores. So I'm going to go do the upgrade real quick and then restart the computer and come back, and we can do the other test and compare it to this one. Alright, so I just restarted, and as you can see, I've done the whole upgrade. We can have all the processors checked they were booted with. And now let's run the second test, exit without restart, and click Run Benchmarks and see what it looks like now. And I'll skip ahead again, and we can wait for the results. All right, so it looks like we're just finishing up now, and this test went much faster than the first one, no surprise. We can get these results as well. And 22,000. Okay, so it pretty much just about doubled. The original one was around 12,000. Exactly double would have been around 24,000, but still, that is almost double. And obviously, there's going to be some error in these tests. And as I suspected, the single core test is about the same. So look, it worked. It got pretty much double the score. And obviously, this CPU is now performing with much more cores and much faster. So this is a really great result. So there you have it. As we showed in that benchmark, there was a huge increase in CPU performance. And as I mentioned before, this is going to remain a higher performance level even if some cores degrade over time. But that's really unlikely. Most CPU cores are rated to last 6 years or more. So by that time, if it starts to degrade, you're probably up for a computer upgrade anyway. So I hope you guys found this video helpful and got just as great an increase. If you did, be sure to let us know down in the comment section how it went and let us know maybe what benchmarks you got before and after. And also, if you liked this video, be sure to give it a thumbs up so I know you enjoyed it. If you guys want to continue watching, I've got some other tutorials on the right hand side. You can just click those or look in the description for the same link like if you're on a phone. If you want to subscribe, I make new videos Monday, Wednesday, Friday, so I think it should be worth it. I'm looking forward to hearing from you guys, so thanks for watching. I will see you next time. Have a good one.